Hello everyone, welcome to SCI-EASE. In this video, I am going to discuss a very important topic of lesson 4 of class 11 chemistry, and the topic is bond parameters. In all, there are 5 bond parameters. So we call 5 B's to this. The first bond parameter, that is bond length. So the first bond parameter is bond length. We come across this term time and again throughout the chemistry, you can say. We will discuss what is the bond length here and how it can be measured. That I am going to tell you. Now, when the two atoms, they are close to each other. Suppose this is atom A and this is atom A, okay? I am telling you about the covalent bond where the radius that can be measured like this. Suppose we have one atom. What is the radius of this atom? First, you should know this. This is the center of the atom. So, from the center to the outermost shell, which is complete, that is known as the radius of an atom. So, here there are two atoms, A and B. And they are touching each other. At this point, okay, when they are in equilibrium, they are like this. Mark the center of both these circles. So, what is bond length? That is when we join these 2 points, the length between the point, this point and this point, that is known as a bond length. Here, suppose RA, that is the radius of this atom A, and RB is the radius of atom B. So, what will be the bond length in this case? Bond length, that will be equal to RA plus RB. Okay? So, what is bond length? It is the distance between the centers of the two atoms, okay, when the atoms are in equilibrium state, when they are touching each other. So, in some cases, like when we take the case of diatomic molecules, where both the atoms, they are of same radius, you can say, we will take the case of hydrogen. In case of hydrogen, what you will observe? That suppose this is one atom of hydrogen, okay, and the second atom of hydrogen approach it, and this is the second atom of hydrogen. Almost they are equal, they should be equal, okay. This is the center of this hydrogen and this is the center of this hydrogen. Now join this, okay. Suppose this is RH and this is also RH, because they are equal radius of both. So here we can say that bond length, that is equal to RH plus RH, or you can say it is equal to 2RH. Okay? So I think this is clear to all of you, the term bond length. Now take the case of some diatomic molecules in which there are two or more than two bonds. So we will consider oxygen. In case of oxygen molecule, there are double bonds between this. In case of this hydrogen, it is HH bond, single bond. Here, they are double bond. And in case of nitrogen, there are triple bonds between the two nitrogen atoms. So what is the difference in the bond lengths of these three molecules? I am going to tell you. In case of hydrogen, there is only single bond, so it will be longer. But when there are double bonds between the two oxygen atoms, the length will be shorter. Okay? And in case of nitrogen molecule, where there are triple bonds, the length will still be shorter. So more the number of the bonds, the length, lesser will be the length of the bonds. This means that this bond that is more stronger than these two bonds, because the atoms, they are close to each other. So I think the bond length parameter, that is clear to you. Now one thing, when I want to break this bond, HH bond or OO bond or NN bond, energy that is required to break the bond. Okay? Here, in case of single bond, where the length is longer, lesser energy that is required to break the bond. But in case of double bond, the energy will be more than this hydrogen molecule. And in case of nitrogen molecule, when we break this nitrogen molecule in two atoms of nitrogen, more and more energy that is required. Okay? So what is this energy? Here we consider 1 mole of the bonds. That should be clear to all of you, that here we consider 1 mole of the bonds between the particular atoms in its gaseous state. Okay, so the energy that is required here, the term is enthalpy. So second bond parameter, that is bond enthalpy. The second bond parameter, that is bond enthalpy. And here we are considering 1 mole of the bonds between the particular atoms, but particular two atoms in its gaseous state. So what is bond enthalpy? It is the energy required to break 1 mole of the bonds between two atoms in its gaseous state. I think the term that is clear to all of you. So when we are to break this HH bond, energy is required. Here also more energy is required than this, and here maximum energy that is required to break these 3 bonds. I can tell you by taking this pen. Okay, it's in my hand, so I'm taking this. Suppose this is the bond length between 2 hydrogen atoms. Okay, so if it is a small stick made up of wood or it is a pencil, I can break it easily by applying energy. But if the bond between the 2 atoms that is of this much length, it's so difficult. More and more energy that is required to break this bonds. So suppose in case of triple bond, the bond length is this much, it will take lot of energy, lot of bond enthalpy that is required to break the bond. So, one relationship which we will deduce from this, that is bond enthalpy. Bond enthalpy is inversely proportional to bond length, okay? And the units for bond enthalpy, that is kilojoules, and it is in 1 mole, so it is mole inverse. Clear? So this relationship we have deduced that bond energy that is inversely proportional to bond length. Now this is the case of diatomic molecule. There are polyatomic molecules also. So I will take the example of water molecule. Okay, I will take the example of water molecule. Water molecule is HOH. Okay, these lengths, they should be equal. So what you will say after seeing this molecule? You will say that equal amount of the energy is required to break this OH and this OH bond. But this is not the case. Different amount of the energy. Suppose here I'm just telling you, suppose there are 100 kilojoules of energy that is required to break this bond. Means first water that will be broken down. That will be broken down into H plus OH. ठीक है? Okay? So, here suppose I am telling you that here energy that is required is 100. Hypothetical, this is 100 kilojoule mole inverse. You will say that again 100 will be required to break this bond. No. Different amount of the energy. It may be more, it may be less. Different amount of the energy that is required to break this bond. Why? To break this bond. Why? Because there is different chemical environment for this OH bond. Environment is different, so the different amount of the energy that is required. So what we will say in that case, that what is the bond enthalpy in that case? In that case, this is suppose first bond enthalpy, then second bond enthalpy. So here we will take the mean of the two or average. Bond enthalpy. It will be 100 plus 80 by 2. 180 by 2, or it is 90. So the term here, that is bond average or mean bond enthalpy. In case of the polyatomic molecules, we will take into consideration the mean or the average bond enthalpy. Now the third bond parameter is bond strength. Or you can say bond stability also. Bond stability. I have told you about the bond enthalpy. Okay? This means more the bond enthalpy, more will be the bond strength or bond stability. How? I have told you that in case of triple bond, more energy that is required to break the bond, or you can say more bond enthalpy is required to break this triple bond. So this means that nitrogen bond strength that is much more than hydrogen bond strength. So more stable then will be the molecule. Okay, so the relationship which I have written before, that is bond enthalpy is inversely proportional to bond length. This was the relationship. This relationship can be extended like bond strength is directly proportional to bond enthalpy and inversely proportional to bond length. Both bond strength and bond enthalpy, they are inversely proportional to bond length. So when you know this relationship, the questions related to these parameters, you can answer them easily. Now next is fourth bond parameter, that is bond order. This is a new term for you, bond order. Here, when we take into consideration the Lewis dot structure for the covalent species, what we deduce from that the number of the bonds between the atoms will tell us the number of, they will tell us about the bond order of that molecule. So, when we take the case of HH, or you can say H2 molecule, where there is HH bond, there is single bond. So, the bond order is 1. The number of bonds will tell us the number of this bond order of that molecule. Now take the case of oxygen. How many bonds? 2 bonds. So bond order will be 2. In case of nitrogen, there are 3 bonds between the 2 atoms of nitrogen. So here the bond order is 3. So one thing I want to tell you here, that when you consider some isoelectronic species, what? Isoelectronic species. What do you mean by isoelectronic species? Iso means, what is iso? Iso means same. And what is electronic? It means electrons, number of electrons. So the species in which the number of electrons, they are same. You take the case of this. Here the number of electrons, they are same. So here bond order, that is also same. You can take this case. F2 and O22 negative, they have one, you can say one bond order. In the same way, you can take N2. N2, there are how many bonds? Triple bond. And you take CO. Here also triple bond. They are isoelectronic. So the bond order is 3. This thing you must memorize. So we have discussed 4 bond parameters. Now the last bond parameter, that is the bond angle. Okay, the last one is bond angle. What do you mean by bond angle? How we can measure this bond length? I haven't told you I will tell you that sometimes I ask the question in the class that how will you measure the bond length between the two atoms? Okay, bond length between the two atoms. One of the student, he answered that with the scale we will measure the bond length. Can you measure the bond length of between the two atoms of a molecule? No, not at all. Why? Because the molecule that is so small, we can't see the molecule with our naked eye. So how can we measure it with the help of a scale? The bond length or the bond angle that can be measured by spectroscopy or X-ray diffraction method. Regarding these spectroscopy and X-ray diffraction you will study in higher classes. Just you have to memorize that this can be measured, bond angle or bond length that can be measured by spectroscopy or X-ray diffraction. This we can't measure with the help of protector or D. Okay, so this is also measured by spectroscopy. So what is bond angle? When I asked some student to draw the structure of water, he wrote like this. So by seeing the structure, we will say that the bond angle, it should be 180. But this is not the case. So the structure, what bond angle tells us? It tells us about the shape and the structure of the molecule. So the structure of this water, that is like this. And here the bond angle, that is 104.5 degrees. Here we measure the angle in degrees. You can take the case of ammonia. Here the bond that will be between molecule of ammonia, H, N, H. So the structure is not like this. It is not like this. Here the structure, that is, it's a bent structure. Okay. The structure that is not like this. Here HNH bond angle, that is 107. It is 107 degrees. You can take the case of methane, where the bond is, structure is tetrahedral. What is the bond angle? Here, HCH, it is 109 degrees or 28 minutes. Okay, so the bond angle, it's very important. The bond angle decides the shape and structure of the molecule. So I think the things, they are clear to all of you. I have told you about these 5 B's which you will come across in the whole chemistry of your 11th and 12th class. Okay, so the basics that should be clear to all of you, that what is bond length, what is bond order, what is bond angle, what is bond enthalpy, and what is bond strength. So that's all for today's video. I will come in the next video and take up another concept of class 11th chemistry. Till then, thank you very much.